Alright, in this video we're going to be talking about the law of cosines, kind of like the law of sines where you have a set of formulas to start with. Right, all three of them. I think most of you probably learned these in geometry. So yes, you do have to memorize them, but once you start working with them, you'll notice they kind of get stuck in your heads. Okay, so here's what we want to think about. If we were to try to use the law of sines for something like this first example, so let me start drawing it out. Okay, so I have A, B, C. Alright, side A, side B, angle C. So what I first want to show is what you have here is a side angle side case. Okay? And what that means is there's only going to be one triangle. And that's kind of nice for this section. There will be only one triangle for all of this section. Okay, so side angle side. If you were to try law of sines, you would look something like this. Sine 20 over C equals sine A over 11. You'd get two variables in that equation, so you can't actually solve it. And if that's the case, then we're going to go to law of cosines. So if I look at my list of formulas up here, I'm going to, for this example, use this last formula because I have angle C, and I'm going to start trying to solve for side C. So if I look at my formula here, here's what I would start writing. C squared equals A squared is 11 squared plus 5 squared minus 2 times 5 times 11 then cosine 20 degrees. Okay, now that first step is fairly simple. You're just plugging everything into the correct formula. So yes, you have to memorize them, but then you're just plugging in. Okay, now here's where we run into trouble. I want all of you to maybe hit pause a second, grab your calculators, try to enter this in, and make sure you get the right answer. Okay, make sure your mode's in degrees, and then we'll see what you get. Okay, so if you did that, here's what we should end up with. C should be about 6.5. So we're going to round those side lengths to the nearest tenth. Okay, now, if you were to go in and start solving for the other pieces, so let me go ahead and put my 6.5 on this side. And I were to say solve for angle A. Let's say I'm solving for this one right here. What would happen is you'd create an angle side case for yourself if you want to use law of sines. So what I would recommend is go right back to law of cosines again. So if I'm solving for angle A, I would use that first version of the formula, and here's what it would look like. I would go 11 squared equals, now that I know B and C, I can say B squared, 5 squared, 6.5 squared, so this is straight formula work now. 2 times 5 times 6.5 times cosine A. Okay, so once again, the formula part's easy, but what you have to enter in your calculator, I'm going to do it out in steps here, and I'll write it all out. You have to do the 11 squared, subtract over the 5 squared, subtract over the 6.5 squared, and then we're actually going to divide by the negative 2 times 5 times 6.5. Alright, and the reason we're dividing is because up here in the original formula that we wrote down, it's going to be that negative 2 times 5 times 6.5 times cosine A. So that's why that part has to be divided over. Then if you calculate all that, what you'll see is, in your calculator, we have to do the inverse cosine of that thing we just found. So what we should end up with, if we do everything correctly, we should have angle A as about 145 degrees. Okay, so angle A, 145. Okay, then the easiest way to solve for angle B would be to just take 180 minus my 145 minus my 25, so angle B should equal 15 degrees. So again, if you go to law of cosines for both parts, it's going to give you a more accurate answer, and you don't have to worry about that angle side case. Okay, so what I want you to do is I want you to try this first example right below that one, and what I'm going to do out to the side, I'm going to write the answers out to the side, and I want to make sure you can get your work to match the answers. Okay, if you do it all right, we should get side B to be about 29.5. We should get angle A to be 123. And angle C to equal 22. So try that example, check your answers, and I'll look at that in class tomorrow. Okay, I'm going to do one more example. This case is, if I draw out the triangle on this one, number 2, ABC, what I've been given is all 3 side lengths. So in this case, I have a side, side, side triangle. So once again, only one possible triangle. Okay, so it doesn't really matter where we start. I'm going to start with the smallest angle first. So I don't know if you remember from geometry, the smallest angle is across from the smallest side. So here's what it would look like based on the formula. 5 squared equals 9 squared plus 7 squared. It's a straight formula. 2 times 9 times 7. Cosine angle C. Okay, and again, if I do all the subtraction and all the division, I should get angle C to be about 34 degrees. And again, you might want to check that calculator work to make sure you're okay with that. Okay, now I'm going to go to the medium one. So now I'm going to look for angle B. So I would do the exact same thing, except this time I'm going to start with my 7 squared. Okay, do all the same kind of work. This first step shouldn't be too bad because we're just plugging the numbers in. The hard part can sometimes be grabbing the calculator and getting that part right. So make sure you slow down when you do that. Alright, what are we doing? Cosine angle B. So again, all the subtractions, inverse cosine, we should end up with angle B as about 52 degrees. Okay, now to solve for angle A, the easiest way to do that is going to be the 180 minus 34 minus 52. So we should end up with angle A as about 94 degrees. Okay, so that was a case where I gave you all 3 sides and you're finding all 3 angles. So having said that, now I want you to try example 3. So when you come to class tomorrow, I want to see example 1 and 3 all worked out. And I guess I could give you those answers to the last one too. If you work out angle 3, show all the work, you should get, actually sorry, this is kind of a weird one. When I work it out, you're going to get it to be no triangle, so no solution. So I want you to show at least the first step in the calculator work that proves it's no solution.